At an observatory, astrophysics graduate students Kaitlin Rasmussen and Devin Whitten observed an extraordinary event some 147 million light years away, something that had never been witnessed before, the merger of two neutron stars. Kaitlin and Devin are here today to talk about that experience and explain some of the science to us. Now, welcome to Notre Dame Day. First of all, we're going to start with Kaitlin. First of all, tell us, what is a neutron star and why were you in Chile?
So neutron stars are actually the remnants of very old, very large stars that have blown up. And what's left is the core of that star. So you get this very, very small, very dense object that's it's actually more massive than the sun, but it's only about the size of Manhattan. And it's made of just protons and neutrons, and it's basically just like a ball of raw material that will get turned into heavier elements. So we are actually in Chile on an observing run. So we were looking for ancient stars in the galaxy and sort of taking their spectra to see if they have the presence of heavy elements in them. So it's kind of ironic, we were actually there looking for traces of neutron star mergers that happened, you know, like 10 billion years ago.
That's incredible. And Devin, how did you realize at the time, like, what you were witnessing, and when did you realize this was so significant?
Right. So we had 5 nights, I think, allocated at the DuPont telescope at Las Campanas, and I think we made it through 2 of those nights when sort of rumors passed through the observatory about a high-priority target that had come in. So we were trying not to get too hopeful, I think, but there's always a little bit of excitement surrounding these kind of things. And honestly, we didn't really get confirmation, in my opinion, until we were at the observatory making the observation, and we were able to compare what this object was doing in the infrared to what we would expect from models of how a neutron star remnant should cool, or a neutron star merger remnant. And about that point, we got pretty excited.
I can imagine.
Yeah.
And Kaitlin, for the average person watching right now, why is this so significant?
So this is really exciting for the scientific community for a lot of reasons. Probably the biggest reason is that this is the first time we've ever had direct observational confirmation that neutron star mergers are actually the site of the production of the heavy elements. Another really big thing is that this is the first multi-messenger observation of anything ever in history. It's the first time we have ever observed an astronomical event in both with light and with gravitational waves at the same time. We've had gravitational wave detections of just black hole mergers, and we've been looking at stars for millennia. But this is the first time in human history we've ever been able to use both of those media to do that.
That is incredible. And Devin, last question for you. How has this impacted your research so far?
Well, I think it's certainly motivated my research, as well as probably everybody else in the field right now. We, as a group, look for the remnants of neutron star mergers in stellar atmospheres like Kay was describing. And so I think we're all kind of invigorated with the idea that not only do these events occur, but they're also potentially quite prolific in terms of their ability to enrich the chemical environment in the Milky Way. But this was an observation of a neutron star merger that was in another galaxy, which I think is actually kind of incredible. We were able to detect that. So I would really personally like to see neutron star mergers in our own Milky Way if they're supposedly a viable option for galactic chemical enrichment. I'd also like to see them in globular clusters, which would be really interesting, as well as the so-called ultra-faint dwarf galaxies, which are these satellites to the Milky Way that we believe are responsible for building up some of the substructure.
I want to thank you guys for breaking it down so most of us understand what you're talking about, and congratulations. We want to thank you guys so much for joining us here on Notre Dame Day.
Thanks.